Dia buka ni dia, YouTube. Dia tak keluar.
Okay.
Okay, go.
Assalamualaikum warahmatullahi wabarakatuh dan selamat pagi. And thank you for coming in for our webinar. Okay. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin. Wassalatu wassalamu asyrafil anbiya wa ala alihi washabbihi ajmain. Rabbi shrahli sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Rabbi yassir wa ta'sir, Rabbi tamim bi khair wa qur rabbi zidni ilma. Thanks God, we can sit here and share to our audience is about the technology around us. Okay, let's quickly introduce myself. I'm the moderator today, Dr. Zaf from Center of Studies Interior Architecture, Faculty Architecture, Planning and Survey, UiTM. Thank you for sparing us for your time to be with us now. Okay, and then without wasting time, let us begin. Start with the ball rolling. I will share a slide. Okay, Mr. Byrne, please. Okay, today we are discuss about indoor air quality, passive and active air purification and air ventilation solution. Okay, if you see the topic, it is related to thermal comfort. Okay, from a dictionary of British, the thermal comfort is defined in British standard BSEN ISO 7730 as the condition of mind which express satisfaction with the thermal environment. The term thermal comfort describes a person's psychological state of mind and is usually referred to in terms of whether someone is feeling hot or too cold. Because thermal comfort is psychological, it may affect our overall moral. Employee complaints may increase, productivity may fall, and in some cases, people may refuse to work in particular environment. Some aspects of thermal environment, such as air temperature, radial heat, humidity, and air movement, may also contribute to the symptom of building syndrome. Not only that, but now the issue is getting the indoor air quality to be purified because the new virus pandemic, COVID-19, and what are the solutions where we can get. Today with us, we have two experts, okay, two handsome experts, Mr. Chang and Mr. Rudy, okay. The panelist, number one, Mr. Chang, is a senior lecturer from University of UniKL, okay, MFI, okay. Basically qualified in mechanical and engineering. Basically, his background is Bachelor Engineering in Mechanical and Material Engineering from UKM 1996, Master's Engineering Management in UPM 2007, and now he's doing his PhD in UiTM, and then he was working in the industry of havoc for the past 24 years. He was a service engineer, head of department, leading the service team in carrying out the daily job for Top Air Sales and Service from 1996 to 1997. He was working in Sunline Service Centers, Sendirian Berhad, as service engineer and promoted to be a technical manager and appointed as one of the company director in 2002. The job that he done, such as JW Marriott Hotel, Star Hill Complex, Pandan Hospital, Ampang Hospital, Sungai Buloh Hospital, Sungai Petani Hospital, Adostar Hospital, NTV7, Star Cruise Terminal, KLIA, and so on. Okay. He has been appointed as technical advisor for so many companies. He had completed his training in NIOSH for indoor air quality assessor in 2016. He have a professional qualification of membership in society in America, Chartered Institute of Building Service, Board of Engineers, research group, and now he is one of the trainers for Ministry of Human Resource in 2019. And at the moment, he is qualified and expert in doing question setter for World Skill Malaysia University Challenge 2021. Okay, and then he has some journals, more than 5 journals in academic journals, and then about 10 proceeding that he in the area of research. Okay, and then the panels number 2, Mr. Rudy bin Yusuf Che. Okay, born in 1985, is alumni UiTM, diploma electrical instrument engineering 2007, bachelor engineering honors electrical engineering 2010. Okay, start working at Daikin Malaysia Sdn Bhd as a product quality insurance engineer in 2010, and then after that got promoted to be a product specialist, and then responsible to represent Daikin, involved in fleets with major Daikin factories from Europe to Asia. Okay. After that, in 2016, it's been promoted to senior engineer consulting sales, serving government sectors, GLC, private consultants, leading a team of engineers and business development. And now he is assistant manager consulting sales, leading a team of consulting sales. Okay, we have a good expert and handsome gentleman here right now. Okay, and then we are talking about air quality, passive and active air purification and air ventilation. And now I will show you some videos to the audience.
It's the 21st century. We live in a whirlwind of technological advancement. I mean, LED light bulbs, self-driving cars, buildings as tall as mountains, even computers would think. Yet with all this technology, we replace this with this. The American spends 90% of their time indoors. Think about it. Buildings are becoming ultra efficient, highly insulated, and what happens is the dirty air is trapped in and the fresh air gets locked out by design. And because of this, it becomes extremely difficult on your work. Poor air quality is very uncomfortable. Circulated air in a building can become toxic. They even have a term for it. It's called sick building syndrome. It can cause chronic headaches, fatigue, sickness, and it's estimated to cost industries over $60 billion a year to people missing work and reduce productivity. So, how does this happen? Let's break it down. Air is mostly made up of nitrogen, oxygen, argon, and carbon dioxide, or CO2, which is only 0.04% of the total volume. Even small amounts of CO2 can negatively impact your ability to think and function. Have you ever had to read a sentence 2 or 3 times to understand it? Probably in a closed space with potentially poor ventilation. Your exhaled breath is made up of high levels of CO2, which means the more people in a room, more CO2 in the air. The average student, they have about 220 balloons full of air in a typical school day. That's over 6,000 balloons in one classroom. This creates 5 times as much CO2 as fresh air. All of that dirty air is then recirculated in your standard air conditioning system. Every year, 18 million school days are missed because of asthma, which is directly tied to indoor air quality, and that's equivalent to the entire student population of Wyoming missing school every day for an entire year. So what would happen instead of breathing this contaminated air, brought in a fresh, filtered, perfectly conditioned outside air? One study shows that a reduction in CO2 doubles a person's brain function. Healthy buildings can reduce respiratory illnesses by up to 76% in humidity and circulation. These simple changes can cut down on airborne diseases and allergies, reduce microbial activity, prevent the buildup. Healthier indoor makes a huge difference. Not only does it make us feel better, it's an environment in the 21st century. Imagine the impact we have on highly effective, dedicated outdoor air system. This transformation could save you millions and cost as little as $1 per person per year. Let's get some fresh air.
Okay, I will leave it to the expert, Mr. T.S. Chang Chu Chek Chiang, to deliver his presentation. Please, Mr. Chang.
Okay, thank you. Terima kasih Dr. Zaf. Okay, kejap ya. Saya share saya punya slide kejap. Okay, selamat pagi kepada semua. Salam sejahtera, salam satu Malaysia. Okay, first of all, terima kasih kepada UiTM sebab sudi menjemput saya ke event webinar ketiga ini. Okay, without further ado, let me start my presentation. Again, I'm CK Chang from UniKL, MFI, University Kuala Lumpur, Malaysia France Institute, Heating, Ventilating, Air Conditioning and Refrigerating section. So today I'm going to share with you all about the indoor air quality and the passive and active ventilation. So these are the content of my presentation today. Then what is the active and passive ventilation? The next, I'll be talking about what is the indoor air quality and what are the indoor air pollutants, followed by the filtration technology, then a little bit on the IAQ assessment, then consequences of bad IAQ, requirement of good indoor air quality, and lastly will be the ventilation in IAQ. So ventilation can be divided into two types. Okay, first is the passive ventilation, and the second one is the active ventilation. So what is passive ventilation? So passive ventilation is the process of supplying air, okay, and removing air from an indoor space, okay, and removing air from an indoor space without using mechanical system. It refers to the flow of external air to an indoor space as a result of pressure differences arising from natural forces. Two types of natural ventilation occurring in buildings. The first one is the wind-driven ventilation. So wind-driven ventilation arises from the different pressures created by wind around a building or structure. And the second one is the buoyancy-driven ventilation occurs as a result of the directional buoyancy force that results from the temperature difference between the interior and exterior. Now let's see what is the wind-driven ventilation. So the air is moving from the higher pressure or the positive pressure to the lower pressure or negative pressure regions. The pressure generated, okay, by natural wind are typically from negative 0.004 to 0.14 inch water gauge. Okay. Then what about the buoyancy-driven ventilation? So the warm air is less dense than cool air, so it rises and creates a difference in pressure, in which turn induces air movement. So this is called the thermal buoyancy or the stack effect. The pressure generated by buoyancy are quite low, ranging from negative 0.001 inch to 0.01 inch water gauge. So in winter, when the indoor temperature is higher than the outdoor, the upper parts of the building, so this part, okay, will have higher pressure, while the lower parts, okay, will have lower pressure. So when openings are provided in these regions, air enter, okay, through the lower openings and escape through the upper. So in summer, okay, when the outside air temperature is warmer, okay, than the building air, a downward airflow, okay, a downward airflow or reverse stack effect frequently exists in the shaft. Okay, and for the mechanical ventilation system, okay, so it is provided mechanically, for example, using the exhaust fan or the fresh air fan, for example, like you install in your toilet or in your kitchen. Okay, now let us to compare between the active ventilation and the passive ventilation. So for active ventilation system, okay, so it provides consistent ventilation that does not depend on natural air current, where passive ventilation does. Okay, again, active ventilation actively works to create airflow instead of just guiding the natural air currents like the passive ventilation. In terms of performance, active ventilations, its performance is not significantly affected by weather conditions, but it does for passive ventilation. But for both ventilation, active and passive ventilations, it helps regulate. They help regulating the airflow in our home. So since we are using power, okay, to turn on our mechanical ventilation, so our active ventilation will increase our energy bills, but it is free for the passive ventilation because wind is free. Okay, then of course our active ventilation system has higher setup cost, but much more efficient at ventilating your attic, garage, or other space. Okay. So after all this comparison, I hope that you all can have a better picture what is active ventilation and what is passive ventilation. Okay, now move on to the indoor air quality. What is indoor air quality? So indoor air quality is a term which refers to the air quality, okay, within and around buildings and structures, especially as it relates to the health and comfort of building occupant. So these are two figures that tell us what is all IAQ about. Okay, so prepared by Department of Environmental and Occupational Health. Okay, so um, most of us or most of the people will spend 90% of their time indoors. But you should know that indoor air quality is two to five times worse than the outdoor air quality. Okay, from the Environmental Protection Agency, the EPA, it ranks IAQ as one of the top 5 environmental risks to public health. And 3.8 million people die annually from illnesses attributable to indoor air pollution. So for indoor air pollution, so there are so many types, okay, like the airborne particles, PM10, PM2.5, that is the particulate matter. Then VOC, volatile organic compound, and carbon dioxide, environmental tobacco, smokes, then moles, all this. I will be talking about all this in the next slide. And some local studies have found that children exposed to poor indoor air quality, like shown in the video played just now, okay, so the students have exposed to this poor IAQ have significant high risk, okay, of the respiratory symptoms, okay, greater risk of upper and lower airway inflammation, and also have lung function impairment. Okay, so for the common indoor air pollutants, so we have the airborne particles, then we have the formaldehyde created or emitted from the paint for the furniture, okay, building material, and then the odors and gases from the activities such as the painting, cooking, and smoking. Now, of course, we have the ozone as well. So this ozone from outdoor air, okay, ground level ozone is harmful to breath. Okay, so that's why early in the morning, please don't go to the forest and then take the deep inhale, because that smell, you feel that it's very fresh. In fact, that is the ozone. Then carbon dioxide from the people exhaling and cooking. So now, as for indoor air pollutant, it can be divided into 3 categories. The first category is the airborne particles. Then the second category is the molecules or the chemical contaminants. And the last category is the biological contaminant. Okay, for airborne particles, for example, the dust, the dental hair, okay, the haze. And for the molecules or chemical contaminants, it includes the vapor, gases, for example, the TVOC, the total volatile organic compound like the natural gas, benzene, ethylene glycol, formaldehyde, toluene, methylene, chloride, xylene. And the chemical like acids, pesticide, carbon monoxide, flammable liquids, welding fumes, ammonia, chlorine, cleaning chemicals, glues, lead, paint, etc. Then odor, the bad smell, okay, the sweat or durians are the very good examples for odors. Okay, chemical contaminants often lead to symptoms which include nausea, eye irritation, and also the skin problems. Then the last category is the microorganism or biological contamination, or sometimes called as microbial contamination. It includes bacteria, viruses, fungus, mold, insect, plants, bird, animals. And then microbial in the airstream may lead to symptoms. Allergy symptoms including sneezing, runny nose, itchy, and watery eyes, tightness in the chest for sensitive person. Okay. Then, now let's talk about the filtration technology. So for the airborne particulate filtration, now we can use a pre-filter that normally installed at the air conditioner. And there are so many types of filters available in the market. So lately, OSHA recommended the MERV value 13 as the minimum requirement in our filtration system. So these are some filters examples installed at the air handling units in our building. Then we have the fiberglass filter, then polyester and pleated filters, and also the washable air filters that commonly installed in the AHU. AHU means air handling unit. So as for the molecular filtration, we are going to get rid of the chemical and also the bad smell in the occupied area. So we have the chemical filters or activated carbon filter. Okay, it is a charcoal or it is a coconut shell but treated with chemical. So that's why we call it as the activated carbon filters. Then we use it to get rid of the chemical and bad smell. So I have designed or installed a few. These are chemical filters for factories, and it really solved their problem. Okay, then EAC, electronic air cleaners, is another type of filtration system to handle the molecular contaminants. So this is the option for us to install, whether we want to install the activated carbon filter as the last stage of the filtration system or not. It's up to the designer or the owner. Okay, then after that we'll talk about, okay, the biological decontamination. So how are we going to minimize the risk of the exposure of the biological contamination? So we can use the HEPA filter. HEPA stands for the high efficiency particulate air filter, and this is a must for us to install at the AHU, at the hospital OT, ICU, ACCU, isolation room, and clean rooms. And it can trap 0.3 micron and larger particles up to 99.97%. Okay, so nowadays also many hospitals, they are AHU, okay, installed with the UVC light, okay, or UVC lamp, okay, because it can kill the coronavirus. Then plasma sterilization system is another example of the biological decontamination system. Just for information, at home you can store or you can keep the hydrogen peroxide, because this is a good disinfectant. When you get hurt, you can use it. Okay, it's very effective. Okay. Then next will be, okay, sorry. Okay, now let me share with you the parameters will be assessed during the IAQ assessment in an occupied area. So there are totally 6 parameters need to be controlled. First one is the dry bulb temperature. So we need to make sure that the room dry bulb temperature achieve the requirement. Secondly is the relative humidity. Cannot be too humid, cannot be too dry. So we have the threshold, which I will share with you in my next slide. Okay, then because if we don't control well about this relative humidity, then we have the fungus or mold growth problem in our building, and this is quite common in most of the building in Malaysia nowadays. Then third one is the room pressure. Okay, so we need to control the room pressure. For example, positive or negative pressure is depending on the application of the room. For example, nowadays, okay, for the hospital dealing with the COVID-19 patient, so we need to create the negative pressure isolation room, because we need to confine the virus in the room from escaping it to the corridor or to outside. So we need to make sure that the room is negative pressure. How to provide or how to create the negative pressure in the room? We just need to make sure that the total air removed or being exhausted from the room is more than the supply. Okay, then after that we need to measure the particle count. Okay, so on different sizes of the particle, for example, like 0.1, 0.2, 0.3, 0.5 micron. Then after that, we need to check about the the air change per hour. So that is the reason why we bring in the what I call the ventilation into our design. This means 1 hour, how many times you want to change the air in the occupied area. Okay, by rule of thumb, if let's say you want to install the exhaust fan, okay, for your toilet, okay, so the minimum requirement is 6 air change. So you can, that means in 1 hour, okay, you need to replace 6 times the air for your toilet. Then only you can maintain the good indoor air quality. The next is the microbiome count. Okay, so microbiome count consists of the sampling for the bacteria, okay, and also for the fungus and mold. Okay, so next, okay, so this slide shows the threshold or acceptable range for the parameters in the occupied area according to the Malaysia, okay, this Malaysia's Industry Code of Practice on IAQ 2010. Okay, for example, for this physical parameters for the dry bulk room temperature. So this is the threshold. This is the acceptable range from 23 to 26 degrees C. And this is one of the test report, okay, for my project, okay, 8 stories building, okay, seems like, okay, certain, what do you call, the certain area, okay, they have the too low temperature, okay, for the occupied area. And for relative humidity, this is 40 to 70% is the acceptable range for our relative humidity. Okay. Then for air movement, seems like 8 floors here cannot meet the minimum requirement 0.15 meter per second, because the requirement is 0.15 to 0.5 meter per second. Okay. So for chemical contaminants, so a few parameters that we are measuring indoor. The first one is the carbon monoxide. We need to make sure that this is less than 10 ppm, that is part per million. And for the ozone must be less than 0.05 ppm. And for the VOC must be less than 3 ppm. And formaldehyde must be less than 0.1 ppm. Okay, for the respiratory particulates, that is the particle count is 0.15 milligram per meter cube. Okay, so for biological contaminant, okay, so we'll take the total fungal count that is less than 1000 CFU per meter cube. So that is a colony forming unit. Okay, then for the bacteria count must be less than 500 CFU per meter cube. As for the CO2, okay, as mentioned in the video just now, okay, so the CO2 level is too high, that is bad to the occupants. The maximum threshold is 1000 ppm. In fact, if the CO2 level achieves 700, then it's alarming us. The CO2 level is already reached the dangerous level, and if above 1000, then it's starting to damage our brain. So it's very important for us to carry out the IAQ assessment frequently, at least once a year. So basically, the bad indoor air quality will cause problems like the SBS, that is the sick building syndrome, and also the BRI is the building related illnesses. So what is sick building syndrome? So sick building syndrome is used to describe the situation in which building occupants experience acute health and comfort effects that appear to be linked to time spent in building, because we spend more than 90% indoors. Okay, then but no specific illnesses or cause can be identified. The symptom can be the headache, the fatigue, the difficulty concentrating. Okay, then however, many of these symptoms disappear or lessen in intensity when a person leaves the space or leaves the building altogether. Okay, so if 20% of the occupants feeling dissatisfied with the environment in the building, then that company should not wait until large numbers of people are ill before taking action. So I visited a factory, okay, an office building, sorry, in PJ, in fact, because their daily MC rate is more than 20 person per day. So it is very bad. Okay, so I visited that building, okay, and it was found, okay, there was no fresh air intake to the air conditioning system, to the AHU. Okay, so very easy for us to solve that problem is just, I just asked them, open the fresh air damper. So immediately they solve that problem and reduce the MC rate. Okay, so now I want to emphasize over here is fresh air is free, and this is the best solution to cure, okay, the sick building syndrome. Okay, then for the building-related illnesses, is used to describe when the symptoms of diagnosable illness are identified and can be attributed directly to the airborne particulate. Okay, so building-related illnesses are caused by exposure to the substances within airtight buildings that have poor ventilation. So symptoms vary, okay, depending on the cause, but may include fever, difficulty breathing, a runny nose, or congestion. Okay, what are the requirements for the good indoor air quality. So the provision of sufficient fresh air supply rate to dilute and remove pollutants. As I mentioned just now, okay, this is the best solution, okay, to cure the sick building syndrome. And second point is to must have the effective ventilation. So providing ventilation where it is needed and in a form that will most efficiently remove pollutants. Yeah, an effective ventilation system will distribute fresh air to the required locations, minimize the dispersal of pollutants, and ensure that their concentrations are minimized in occupied areas, just to dilute it. Okay. The third point, low external pollution concentration. So this poor outdoor air quality will have a significant impact on indoor air quality. So the external pollutants include the vehicle exhaust, discharges from the combustion appliances, industrial process and power station exhaust. Fungus spores and pollen from vegetation may also cause air quality problems. And the last point for this requirement is the low pollutant emission rates from internal sources, including materials, for example, like our furniture, our carpets at home. Okay, so we need to make sure that, okay, we always clean all this material at home. Okay, so ventilation in IAQ. Okay, so ventilation can help to remove or dilute indoor airborne pollutants coming from indoor sources. Okay, so this reduces the level of contaminants and improves the indoor air quality. So the introduction of outdoor air is one important factor in promoting good air quality. Then how air may enter a home. So there's several ways, okay, for this air enter our home. For example, through natural ventilation, such as through windows and doors, through mechanical means such as through outdoor air intakes associated with the heating, ventilating, and air conditioning system, then through infiltration. Infiltration is a process by which outdoor air flows into house through openings such as the cracks or joints in the wall, floors, and ceilings, and around windows and doors. Then, how much fresh air intake needed? Okay, adapted from guidelines from CSIA and ASHRAE, CSIA Guide A recommends minimum fresh air rate of 45 liters per second per person. Okay, so how many people staying or sitting in a room, for example, in classroom, then we need to multiply with this 45 liters per second. Okay, then only we can dilute the CO2 level in the occupied area. Then typically inadequate ventilation may be due to insufficient supplies of fresh air. So excessive recirculation of air, that means 100% returning the air indoor to our air handling unit and supply to the occupied area again. So there's no fresh air intake. Then poorly maintained air handling unit filters not replaced when needed, okay, or a poorly designed or installed of the ductwork system. So a better indicator of air quality problems due to poor ventilation is to calculate the ventilation by measuring carbon dioxide concentration in the breathing zone. So that's why carbon dioxide level is one of our measuring parameter when we carry out the IAQ assessment. So last part of my presentation, so I'm going to share with you some photos, okay, taken during my IAQ assessment in one of the office building. So the first one is the spreading growth of the microbiome on the agar plate. Okay, this is by swab test and also by the assembler. Okay, then we have the water leakage either from the condensation of the ductwork or the leakage from the water pipe. Okay, and we found that mold grow, okay, everywhere on the ceiling. Then if you can find the dusty air supply grill and also the dusty supply air duct. So this is inside the duct. Okay, so we will put our robot, okay, or cleaning robot into the ductwork, and we can do video recording and we can inspect the condition of our duct internally, and we can do the cleaning, and after that we can do the swab test, see whether, okay, there's any bacteria or mold grow on the duct surface. Okay, so more on furniture. Then after that, water leakage, dusty air filters. So when we found that, okay, we have this so dusty air filters, that means our environment is very dirty. Okay, then we have the high TVOC level and also high CO2 level. Okay, when we notice we have the very high CO2 level, means that there's less fresh air intake to that building. Last slide of my presentation. So this is the sign of the bad IAQ during the sidewalk. Okay, so there's a dusty filter and then dusty air return air grill, and then dusty toilet exhaust, and then improper return air grill, the mold stain at toilet and malfunction toilet louver. So you all can look up at your ceiling. If let's say now you're sitting in your office, see whether your supply diffuser or your return air grill is dusty or not, because it determines your quality of your indoor air. So that's all for my presentation, and thank you very much and so long. Thanks for your time. Thank you.
Oh, thank you, Mr. Chang.
Thank
Wah,
you, Dr. Sao.
I dah lama tak dengar lecture from the on services actually.
Oh yeah, guys.
That's good. And
Thank you,
then
thank
very
you.
informative, and then good info for the listeners. Okay, I go to Mr. Rudy Azman, Assistant Manager for Daikin. You can share now, Mr. Rudy.
Yes,
Thank
yes.
you.
I'll share right now. 1 second.
I need to stop sharing, but
Yes.
how to, because seems like I lost my window now. Expand.
I think
All right.
I'll just
Okay.
overlap it. Yeah, no problem.
Okay. Thank you.
Okay. Assalamualaikum. Salam sejahtera. Good morning. Thank you very much for pihak UiTM FSPU to invite me and Daikin Malaysia Sales and Service. So basically, my name is Rudy Azman bin Yusof Shah. I am from Daikin Malaysia Sales and Service. Been here for the past more than 10 years. And basically, I am also a UiTM ex-student, as explained by Dr. So today I saw Mr. Chang's presentation. I think most of my presentation is actually similar to him, actually. But I will go through very fast. I just during his presentation today, I just whatever that is like overlapping with him, I just remove it altogether. I just keep the basics one. Okay. But yes, a lot of what Mr. Chang just explained is actually the most important things in IQ, of course. So basically, like Mr. Chang explained earlier, and you as well, you explained the same thing. Basically, we have in IAQ, we have for us, we have this 5 parameter that we need to take care of, right? So basically, it's first is the ventilation. Of course, ventilation conceptually, you have to pump fresh air in, and you have to vent the stale air out. Second one is circulation. The third one is the filtration. The last one is basically the AC part, the humidity and the temperature. So basically here I have like the key parameters you need to take care of. CO2, circulation, filtration is the same thing as Mr. Chang just explained just now. Relative humidity uh, and temperature. Basically you can calculate by three main things. Yeah. First is the ventilation, which is covering the ventilation and circulation. Second is the filtration, and the last is the AC part of it. So this is we have a lot of guides right now, like Doctor explained earlier, because of the pandemic recently, everyone has a higher awareness level for IAQ, of course. Before this, it's been there for as long as I can remember, from the beginning of time, maybe. But nobody really put an emphasis on this, other than the ones that is doing the HVAC ventilation system. Yeah. So let me move forward here. Okay. So basically, this is the same thing that everybody has already explained. More than 90% people stay in indoors. Yeah, we spend a lot of time in indoors rather than outdoors, of course. Key things here is the pandemic. Let me have a pointer over here. Okay, it's the pandemic that raises the concerns and awareness of IQ. You have a lot of asthmatic, rhinitis, and pulmonary stuff. 1 second. So there is long-term and short-term effects. Headaches, eye, throat. This is what already explained before, and there is all long-term effects. So this is all the same thing that Mr. Chang already explained earlier. So I will not go through this very deeply. 1 second. Like it's not working. Okay. Oh, sorry. Okay. So in any design of a building, so failure to address IAQ during design and construction or lacking in commissioning will have all these IQ problems. Moisture in the building assemblies, poor indoor air quality or outdoor moisture, altered in the ventilation system, like Mr. Chang has shown in the ducting, in the ductworks, indoor air contaminants, inadequate ventilation, ineffective filtration, and cleaning. So the next slide, I will basically show how you going to basically solve this problem. Like in the market right now, when you have the idea of introducing fresh air, you will basically uh, pump in fresh air, as simple as that. So you will solve your problem. But by doing this, basically you are going to increase the load of the room itself. So this is one of the problems that we have facing in the Malaysian market right now, where we do have a certain level of awareness on IAQ. We pump in air, but it is untreated, right? The whatever air that we pump in is untreated without any pre-cooling or filtration. So fresh air increases in the air, will increase the air conditioning load, basically, and also bring more pollutant into the indoor environment. So, okay. So basically, when we do any planning or design, we have to take all this into consideration: ventilation, air processing, humidification, filtration, and most importantly for us in Daikin, because we are putting a lot of emphasis on energy efficiency, is the energy recovery, right? So every time we pump in, so we have a lot of products, of course. I don't want to do this in a product. I don't want to be product driven. So I just want to show you like what we have very quickly. So it's fresh for ventilation. I will show you how does it do after this. And you have this pure, we call it pure. It's actually filtration. So there's two parts of here: ventilation, and then you have purification. In a way, it's filtration. And then you have your control system to help you basically to manage, to really see what is the indoor air quality of your building or the rooms that you are in charge of. So the first thing what you can do is basically you have an outdoor air processing unit. We call this an OAPU. So you pump in air but before you pump in air, you basically pre-cool it. So you pre-cool it to a level that is comfortable to be discharged in the room. So in this particular simple design, you will have positive pressure in the room, right? So when you have a positive pressure in the room, whatever is the same concept as you go into a mall. So if you go into a mall, when the glass door opens, you have this gas chiffon, right? So this gas chiffon is by design, purposely by design, because what the mall wants is a slightly positive pressure. So when the doors are opening and closing, when you have traffic, you don't bring all together your dust inside you. If it's neutrally pressured, so you will bring in dust, you bring in whatever you come, whatever that is from outside, you can bring it in, right? So this is a positively pressured room. So this is one way to do it, to do your ventilation. And then another one is heat reclaim ventilators. Yeah, like I explained to you, when you bring in fresh air, you need to increase the load of the room. So when you bring in air, you need to exhaust it out. So when you exhaust it out, you basically throw away all the air that you have just spent a lot of money to reduce a bit, to bring down the temperature. You just throw it out. So instead of doing that, we reclaim it before we reject it out, right? This thing right now, reclaim is not just temperature, but now even humidity can be reclaimed as well. So these are just a simple design for rooms, for office, for hospital rooms. So we can do. But I know in Malaysia, in like this TS Chang already designed a lot of hostel. A lot of hostel is doing 100% fresh air and pulling it out. Yeah, that one is another issue that we can discuss. So another thing is reclaim with additional cooling. This is the same concept, but it's additional cooling. So basically, I have prepared like all the slides based on the conceptual questions. So I'm not sure if Doctor, if I go this one by one, or basically you want to go, you're the moderator. So how are you gonna do it?
Okay. Thank you, Mr. Rudy.
Yep.
Thank you so much for your refreshing presentation, and then it's about relate the issue with technology solution.
Yeah.
Okay. Okay. At the meantime, okay, you can really answer the question that we give to you. I leave it to you, Rudy.
Okay.
Before we wait for the question from the listeners.
Oh, sure. So, based on the questions, I just do a quick slides for all the questions actually. So basically, the first question that was posed is types of indoor air quality. I think Mr. Chang already explained earlier, and TS Chang already explained earlier, and I explained is basically you need to have these 5 key parameters: the CO2 level, the air movement, the filtration, the humidity, and the temperature. That is the thing that you need to take care of. Okay. So the second question is, what is passive and active? Yes, Chang already explained as well. It's the same thing. So on the passive side, on this right side, I just put up. This is where you create passive ventilation. Yeah, this is in the concept of a house. So you have larger opening on one side, a smaller opening on the other side. You basically will create a pressure difference. So when you have pressure difference, you have free ventilation. This goes for like architects. I think a design of a building itself, between buildings, let's say you created a gap between the buildings, and the gap is not asymmetric, then you will create a pressure difference. So you will induce that passive ventilation. It's free, like Mr. T.S. Chang mentioned, it's free. It's just the way you design it. And then you have the active one, which is the mechanical one that I just mentioned earlier. So this is all the mechanical. So this is between passive and active. Let me go through here. Okay. What is the best solution for indoor well-being and health? This is 2 parts I mentioned earlier. You have the fresh, you have the pure. So the fresh here is really is ventilation basically, ventilation and filtration. Okay, so you have these two, then you'll be set. Okay, how does it work exactly? So how does it work? Basically, the slide is very self-explanatory. This is all mechanical ventilations. It's just the matter of you want to create a positive pressure room or negative pressure room, depends on the application. You can do heat reclaim. There's actually a lot of ways you can do this in a proper and efficient way, because other than the IAQ, we are also spending a lot of money in energy. So if we can do a really sustainable building, sustainable design, that will be help us a lot. Okay. This is the pure part, like how exactly it works. Okay. So you have filtration units over here. You can put in the ducting a filtration unit. So this one you can filter PM 2.5, PM 10, like Jess mentioned, carbon filter, carbon active filter, UVGI. Yeah, it's the same thing. If you can put in a this is the ducted unit, and then this is the filter chamber in a way. And then I will share to you on like purifier. When everybody talks about purifying, everybody think about this particular contraction, right? So I'm just going to basically show you how this one plays out. Oh, somehow I cannot play this. The video doesn't play now. Second.
Baca bawah.
Mr. Lee, it's no sound.
Okay, so I hope the video is can give you some idea on how does it work for your normal typical air purifiers, and then the best way to purify the air. So basically, the best way to purify the air is first is dilution. Yeah, dilution is the dilution of the air concentrated in that volumetric of the room. So you have to vent in, pump in new air and vent out the old air. So basically, it's dilution. And then you have the filtration part and the climate control part, which is the temperature and humidity. Second. Are you guys hearing me well?
It's okay. Tadi the video tadi.
Oh,
Ah,
okay. I thought
only
the video.
video.
Oh, maybe I share it. I didn't click the thing. Yeah, I didn't click the. Sorry, I think it's my mistake. When I share it, I didn't click the optimize. Okay, sorry. I just going to go further. I will answer the questions later on. So how effective is indoor air purifiers? This is a very good question, because if you go to WHO, you go to DOSH, or you go to KKM, they will encourage you to use air purifier. They are encouraging, but in a lot of ways, it is considered as emerging technology. So in Daikin, we basically have a research institute. This is a Daikin Streamer Institute. You can browse this. This streamer is actually our purifier. We have an institute just for the purifier, and we do testing since back in 2004 until now. So these are the results of the tests that has been done, the research that will be done, joint venturing with government sector, some university mainly. So if you can see here, you can browse it and you can see what we test. We test on viruses, bacteria, allergens, hazardous gases, which is VOCs, and then moles. So you can go to the site and basically see the results. And it is mentioned here what is the test method, when it is done, And basically the latest one is the one that I highlighted, which is the novel coronavirus SARS-CoV-2, aka COVID-19. So we tested this in 8th of July 2020 actually. So you can see the results over there. So basically saying the unit is effective. The unit is effective. So what's good in the quality? I'm going. Okay, what's good in the quality? I think is the question is the same. I will go on further. What is the disadvantage of air purifier? This is the one that Chas mentioned earlier. When you go out in the morning, you have that deep breath, you feel very refreshed, but that is actually kind of dangerous because that is ozone. Ozone is O3. So in purifiers, there is a lot of purifiers out there, especially the one that is creating ozone. Yeah, because it is highly debated on ozone exposure of ozone for a long period of time. So ionizers in your ACs, in your purifier, we have these ionizers. So these ionizers, the work is basically to break down all the viruses and molds. So, but there are also a byproduct of ionizers, which is creating this ozone O3 molecule. So this is one of the disadvantages, which is still in heavy debate. And then, of course, the regular cleaning and maintenance needed for the air purifiers. Okay, because it requires more cleaning and more maintenance actually, because of the high grade of filtration material. It catches more stuff and you have to more clean it more frequently. And then how much space that air purifier can cover. Of course, if you are going to the typical air purifiers, it is around 31 meters square to 41 meters square per unit. But in purification, in filtration, virtually there is no limit because you can put in an AHU, you can put it in your duct network, all these like PM2.5 filters, we can put it in your duct network. So there is no issues or no question about how much space that you can purify your air. So how do I know indoor quality if I have an indoor quality problem? So this question is relates to the virus, right? To the virus, to the CO2 emission, but most importantly, people are asking like how I know like that particular room is okay and is not going to have a breeding ground for viruses and bacteria. So virologist already mentioned that basically you don't have a sensor to sense the virus, so you can replace it with a CO2 sensor, because a CO2 sensor will show you how good or how well a room is ventilated. So you can use CO2 sensor as an indicator that the room is good in ventilation or not. So this is one way to do it. Basically, you put sensors, IQ sensors, we call it. These IQ sensors, we can detect CO2 sensors, PM2.5, PM10, TBOC, temperature and humidity, and report it back to a centralized system, and basically can go to your work control room or to your phone. Okay, you can live monitor everything in your phone or in your workstation lah. So this is in a way is a very high tech, but if you have minimal, the most minimal is a CO2 sensor. I think a CO2 sensor is very easily available in the market. 11, 12 basically is the common air pollutants and the biological chemical. There is a lot of things in the air actually. So TS already explained like PM2.5, PM10, VOCs, bacteria, mold, and dander. Dander is from pets, from humans even. Okay, so these are the short-term and long-term effects of all these pollutants in the air. So okay, so how much ventilation do I need for my home to improve the indoor air quality? Actually, there is a standard, the ASHRAE standard. So you can basically, if you can see here, I just crop out the residential part of it because the question relates to my home. So this is basically how you calculate it. You have how many CFM per person and how many CFM per feet square, or liter per person or liter per meter square. So basically the concept is very simple. You times how much a person needs times the pack that you have in the room plus how much fresh air that needed for a feet square or meter square for a room times with uh, the area of the room. So this is just a quick example, 1,400 square feet with 4 packs, like a house, a big house. So you need like 104 cubic feet per minute. So this is a very quick calculation, and it is available. Usually the mechanical engineers will or consultant will calculate this for you guys. But it has, in this book, it has a lot of other application. Of course, different application. Let's say an office with 1,400 square feet definitely will not be just for people, right? There's going to be a lot of more people. So there is a different application like office, kitchen, gyms, and whatnot in the book. So what can I do to improve indoor air quality in my home? What are ways to prevent the spread of COVID-19? So this is a guide from Ministry of Human Resources, DOSH, and also the Ministry of Health. It was published on July of this year. Second. So this is the guidance for ventilation indoor air quality for residential during pandemic, COVID-19 pandemic. Yeah. So the first one they recommend is to operate exhaust fan to improve ventilation. Okay. The second one is to set your temperature of your AC to become 23 and 26. And then open window frequently for natural ventilation, or passive ventilation. Number 4 is improve thermal comfort by using electric fan. And then recommended to use air cleaners. So basically, if you see this is related back to the 5 points, 5 key parameters that TS and me already mentioned earlier as well. So this is what you can do at your home, basically to increase, to dilute as much as possible the air. Yeah. The last part is the aircon part. The thermal comfort is the last thing that you want to take care of in this pandemic time, of course. First thing is the dilution and the ventilation that you need to take care of. So I think that is basically all the conceptual questions. So I pass it back to you, Doctor. Thank you very much.
Thank you, Rudy. Kalau I jadi lecturer, I bagi 100/50/100. You give more answers to the question. Okay, thank you so much, Rudy, for the excellent explanation. Kita pergi kepada soalan-soalan, ya, soalan-soalan yang daripada listeners. Do indoor plants improve air quality? May T.S. Chang give some comments?
All right, okay. So in fact, I have done, or I published a paper, okay, in the journal using 3 or 4 different plants to improve the indoor air quality. And it is proven that if, okay, so we put our plants indoor, okay, it can trap the particulate or airborne particles, and also they will improve the temperature. Okay, but it will increase the CO2 level in the night time, because during the respiration, so they are taking in the oxygen and they are emitting out the CO2. So at night, it is better for us to put our plant outdoor. But if, let's say, you open your window, okay, at night time, then it will dilute the CO2 level indoor. So basically, a money plant the chrysanthemum, okay, and also the ficus plant can improve our indoor air quality. Okay, so that is one of my research done, and I published in the journal this earlier of the year and presented in the international conference in Bangkok. So it's proven. And if you want to Google, in fact, NASA also did some research on that, the plants whether can improve the indoor air quality or not. Okay, so memang boleh. Okay, tapi pagi-pagi okey lah sebab fotosintesis dia ambil dia ambil CO2 dan dia emitting the oxygen. Okay, tapi at night kalau you tutup tingkap semuanya tu better don't, especially don't put next to your bed. Okay, sebab dia dengan you akan rebut okay dengan oxygen tu. Okay,
Oh.
I hope I answer your question. Yep.
Right. That means it's a good tactic.
Ya, betul. Ya, sebab saya punya research yang itu include dengan yang evaporative cooling sebab ada tuan rumah yang dia bela ikan kan, ada aquarium kan. So saya punya aquarium saya letak kat bawah dan lepas itu saya punya pokok tu tiga layer, 4 layer, okay. Dan lepas itu saya ada satu aquarium pump, saya akan pump air itu naik ke atas dan lepas itu siram pokok itu, at the same time dia akan turun. Saya ada yang kipas kecil, komputer punya kipas yang kecil tu, okay, letak kat belakang dan lepas itu saya draw the air, push the air through the filters dan kami ambil temperature RH dengan IAQ punya reading di depan dan di belakang pokok saya punya filtration system tu dan memang ada improvement lah. So pun cantik. Okay, so saya punya student pun letak dengan lampu-lampu ke atas yang neon lampu warna biru. So nampak aquarium ada ikan dan lepas itu ada pokok-pokok hijau dan lepas itu kita pun boleh bring down the temperature. Tapi kalau kita selalu tutup tingkap ke pintu ke, saya tak encourage lah. Sebab apa? Sebab dia punya relative humidity akan naik. Okay, jadi ini memang suitable untuk yang macam coffee house yang ada outdoor kat luar tu. Sebab kalau outdoor biasanya kan ada kereta kenderaan lalu lalang kat depan tu kan. Jadi ada banyak habuk semua itu. So dengan yang filtration system yang ini, dengan yang evaporative cooling, dia boleh bring down temperature, dia boleh trap kita punya dust. Okay, kat outdoor tu. Okay.
Then the bamboo pun better lah kot.
Ya, bamboo. Yep. Yes, betul. Ya, ada satu lagi pokok yang 4 pokok tu, satu ialah bamboo palm.
Bamboo palm
Bamboo palm. Ya.
Because the 35% dia punya oxygen is better than other
ya, ada plants. Ya, pokok yang lain betul. Ya.
Okay, Mr. Rudy, ada question from the listener. How to move out the hot air quick from our house? Your mute. Your mic.
Yeah, coming. Sorry. So how to move the hot air out quickly?
Yes.
Okay, so the quickest way is basically a fan. You put an exhaust fan, you exhaust it out, so new air will come in naturally from the cracks and the leaks and whatnot. So that is like the easiest way to remove hot air out. It's like your kitchen hood, right?
Okay.
When you're cooking, the first thing you need to do after the cooking starts is the exhaust fan right on top of your dapur. Then it goes exhaust out as quick as possible. That's the best way.
Okay. And then how and what is the best way to apply and maintain the indoor air quality regard to sustainable and affordable housing scheme?
Of course, in this, I think from the very beginning of the design stage, I think architecture or architects plays a very major role in this. Okay, if you want it to be sustainable, you have to reduce mechanical ventilation as much as possible, but you still need the ventilation, right? So in terms of design, I think the architects is the key person to design a building in such a way it optimizes the natural ventilation, so you can later on your building will be more sustainable. That I think that is the keyword here. But if you have, because you say affordable housing, so if you're talking about a normal house, I think the best way is to have a normal amplifier, have a small exhaust fan out. You need that flow, and that should be okay. But if you are designing a town, let's say, so like where it is located, the arrangement of the building, or where is the park you put your pokok, where TS mentioned pokok definitely will help improve your IQ. That's the key. I think the key thing in order to have this result of apa panggil sustainable design.
Sustainable design. Yeah. Okay. Okay. For Mr. Chang, let's say about terminal comfort. What is the ideal thermal comfort inside the house without aircon, and how to achieve that?
Okay, so when we talk about the thermal comfort, right, there are so many factors affecting the thermal comfort. For example, like the humidity, the clothing insulation, so what are we wearing, and the metabolic rate, what are the activities that you are doing or performing at home or in your room, and also the airspeed and the air temperature and radiant temperature. But if, let's say, in Malaysia, if without this what we call the air conditioning system installed, because we are the hot and humid country, so the whole year. So even you open your window to let the good indoor, the circulation of the air, okay, the ventilation good in your house, but still sometimes we can achieve the temperature, okay, at 23 to 26 degrees C. So for me, it's quite difficult, okay, if let's say, okay, we can't achieve the temperature and the relative humidity because we are so humid, okay. So even our normal air conditioner, okay, they only can bring down the RH to about 65% RH. Of course, that is the human comfort level, okay. But if without air conditioner, because air conditioner is the one to take out the moisture or bring down the indoor relative humidity. So without the air conditioning system, it is quite difficult for us to maintain, okay, or to achieve the thermal comfort indoor. Okay, so if let's say for season country, yeah, it's quite we can maintain that, okay, because it's depending on where is the country, okay. If let's say the UK, then they're always quite dry, and then the temperature also even at the summer also 26 degrees C. That is our required temperature for the human comfort. Okay, so that's why I say in Malaysia, without air conditioning system, it's quite difficult for us to achieve that room temperature, if especially in the noon, okay, or in the afternoon. But at night, shouldn't be any problem.
Okay.
At night, sometimes outside air is it's colder than inside. So for example, my kampung house, okay, so most of my bedroom, so we install with the exhaust fan. So we turn the exhaust fan on at night to extract the hot air from the room, okay, and they automatically they will draw in the cold air from outside into the room, and then I can sleep comfortably. Excuse me. So this is how we can maintain the good indoor air quality, and also can try to maintain the good thermal comfort indoor. Okay, so I hope I answer your question.
Okay, right. Thank you, Mr. Chang.
Thank you.
Mr. Rudy,
Yeah.
tadi I rasa ini ada you tunjuk tadi, tapi still people want to hear from you. Is there any medium we use to measure that would make us alert with our house indoor air quality?
Okay. So there's a lot of various sensors that is in the market that you can use, right? So because as the beginning of the forum, we mentioned that all these VOCs, all these bacteria, dander, we basically cannot see with using our naked eye. So how we measure it is using sensors, of course. So the best sensor that to know is a CO2 sensor to represent the overall ventilation condition of a room. So if you have that, the most basic one, which is CO2 sensor, and it's hooked up to a system that is going to alert you through your smartphone or whatever. So you can basically know, right? If you have your own solution at your own home, you have a CO2 sensor connected to, I don't know, a simple thing as a light showing green is good, red is not good. Basically it's the CO2 sensor. You have a setting you can set for 1000 ppm or 800 ppm. So basically when you set it, whatever above 1000 ppm will give you like a red light, right? Then whatever below 1000 ppm, it will give you a green light. So basically that is a good indicator if you want to put it in your own home. But if you are designing a big building like multi skyscraper or something, so you have a better to have a centralized system that you can monitor every floor or every room, depends on your design. That is the best way. Basically is using sensors. Yeah.
Okay. Mr. Chan, in your opinion, what is a potential research topic related to indoor air that can be focused on right now?
Okay, so good question. So a few topics that you can focus on. That first is the air velocity, air movement in the clean room, for example, the OT. So now our requirement is 0.3 to 0.5 meter per second. So you can study whether we can reduce it to 0.15 meter per second. Okay, and then see what is the consequences if, let's say, we reduce the airflow requirement, okay, or the velocity, sorry. Then second topic, maybe you can think about, because nowadays most of our typical design for our OT, so I'm talking about the OT hospital design right now, because this is very important for us, because the conventional design is the laminar airflow from the what I call from the perforated supply diffuser, okay, on the ceiling. But maybe you can think about using CFD to do simulation. We change, okay, the airflow type. Instead of downflow, and our exhaust is on the low level on the wall. Then you can think about, we are using the displacement airflow using the CFD to simulate it, see whether it is good, okay, for we can have a better what you call indoor air quality control. Not only maybe not only limited to our hospital. You can think about a school, because most of the school right now, okay, especially now students, they are going back to school. And some of the school, especially the international school, if let's say they're equipped, the classroom equipped with the centralized aircon, maybe you can study on this, okay? Because like just now in my slides, and also Rudy's slide, so we mentioned about the bad indoor air quality for the school as well. So the small kids were exposed to all these contaminants. So maybe you can think about this, okay? See whether how can we design, okay, the airflow pattern or airflow distribution pattern, not necessarily must from the top, okay. So we have another what we call another design. In fact, next month, early next month, I'm going to present to MOH about the new flow pattern. Instead of the conventional type, the supply diffuser is on the top. So now we are doing is a curve. It's a curve on the cornice, and then our airflow is from there and then directed to the operation table. So we can study on that. We are using the CFD to study, okay, the result, see whether we can have a better indoor air quality for that clean room and environment or not. Okay, so there are two studies really. Then maybe another one is you can a study on the because the what I call the filtration system. Okay, so we have to use 100% fresh air. So we need to have 3 stages, minimum 3 stages of the filters in our air HU. So maybe you can think about, is it necessary we must use 100% fresh air design for this? Okay, so if not mistaken, in US, they are going to start this design is not 100% fresh air. Okay, so as long as we can do treatment on our recirculating air, okay, then we can save a lot on the energy. Everybody now talking about the environmental friendly, and we want to save our environment. We want to minimize the climate change. So it's better for us to think about, because when we take in 100% fresh air, then our pre-AHU then or our cooling coil will be very, very huge. And when we have this huge AHU, then the power consumption will be very, very high. When power consumption very high, then CO2 emission will be high, and it definitely will directly affect our climate change. So maybe you can think about all this design. Instead of 100%, can you reduce it? Because if we reduce 30% of the fresh air, we can reduce a lot on the cooling load. Okay, and also the filtration, the filtration system. Okay, so so far these are the topics that I can think about that. Okay, thank you.
Good topic to do a research then. Okay, Mr. Rudy, last question. By changing to dry mode function of the aircon, could it give a better IAQ compared to cooling mode?
Okay. So basically, the dry mode as basically what does it do is drying out the air, right? So instead of you have let's say you have a high, low, medium thing on your air conditioning unit, right? So when you switch it to dry mode, it automatically will go to the lower setting. So lower setting here means like your air movement is going to have the lowest one, the lowest air movement. So lowest air movement when it interact with the fin, the coil, the cooling coil. So you will have more time of interaction. More times mean more condensation will happen in the evaporator. So basically that is where it is pulling out as much water as possible out from the unit, from the written air, but it really doesn't relate to IAQ really. Nothing to do. It's just drying up the air, but your air movement will be lesser, of course. But this one is going to, like I mentioned earlier, and TS also mentioned earlier, your air movement is something that you need to take care of as well. Humidity, you'll be okay on humidity because you are putting it on dry mode. So basically, to answer the question, it's no, it is not going to help your IAQ at all. It's basically to have this. If you, maybe I can change. I can address one thing. Like we Malaysian, yeah, we Malaysian, we have this idea of if if I can feel the air on my face, like air movement on my face, then I have AC. Right? We have this concept because before this we are from our, when we are kids we have kipas before we have aircon. So the kipas is always there, right? So that's why you have this idea of like putting a small string on the aircon, small string just to see if it's really turned on, right? So let's change that idea to thermal comfort. Thermal comfort means here is not like wind blowing on your face. No, thermal comfort is where you feel comfortable. You are not sweating, right? But you don't have to have literally air movement on your face. So this is a concept that we basically need to change because we are actually using and access a lot of energy for air conditioning, of course, because like TS mentioned, we are in a hot and humid climate here in the country. So that's why the KKM, the Dodge is recommending 23 to 26. For me personally, I would prefer 25 and that's it. No lower, no higher. Because we Malaysian, we go in and we just put like 18, 17, you know, as low as the setting can go. So that is a very bad habit, and it is using up a lot of energy and creating a lot of CO2 footprint. One thing I would like to share, addressing back to the previous question to Mr. T.S. Chang, the potential research studies. I am very interested on what you shared earlier. I would like to share something, just a quick one. Now, if everybody see this, 1 second, I share this. Okay, everyone see this website? Okay, so this is our, we call the Daikin TIC, Technology Innovation Center in Osaka. Okay, this building is aiming for a net zero energy building. Net zero means here it is, we are using the building as it is, but we are net zero, means like the energy that we use is net zero. So in this particular technology, all the Daikin, our technology is here in terms of not just the product, but also the design. Like TS mentioned earlier, we usually discharge from the top, right? In this building, we have discharge on the top, discharge on the floor as well, because we are testing it. What is the best way? In terms of architecture, also we have this shadings, where it is basically shading for the ground floor, but it's also providing lighting for the upper floor. At the same time, it's providing lighting for the upper floor. So basically, it's to reduce the load, and to reduce the load of the building. Basically, we aim for a net zero building. So this is the background, and actually, this is the aims. We're going to aim for net zero in 2020, but last time I heard we haven't achieved that yet because it's in R&D stage, you know. But we do have collaboration with universities, lecturers that have a very interesting topic that we can do it as a fellowship in the TIC. So we do have these JVs with local university, international universities, that you sit in Osaka, you do your research, everything is there. So this is basically what we as Daikin do in R&D in terms of creating a more sustainable future for the next generation. Yeah. So if you can see here, there's like solar panel. This is very interesting. Where TS Chang mentioned about his kampung home. Okay, so here you can see here, this is one of it. Like in our kampung home, we have this, it's elevated, right? Under the house, we have this area where under the house, right? So the under the house is basically the temperature under the house. If you go outside on the sun, it's like one temperature, which is higher. Then you go under the house, you have one temperature that is lower. Actually, in this building, also take the same approach, where you have a lower part that is hollow, that is cooling down the air. Then we pump that air back out to the rooms. So this is one way we do it. Actually, this, when I look at it, when I visited and look at it, it's actually same like our kampung house. Take it from the underneath the house and just pump it out to the next floor, to the next floor, to the next floor. Basically, from the result that I see, if I can remember correctly, you have a difference, 5-degree difference. So it's like free cooling 5 degrees under the house comparing to the outside. But of course, under the house, they also create an artificial park just to let through the air, go through the park first, through the trees and whatnot. It's like a beluga, you know. When I ask, is it a beluga? No, it's actually intentionally it's done like that to make as much vegetation as possible first. Let it through the thing, through the beluga, and then muscle under the building, then pump it up. And actually, they are saving a lot of energy in terms of aiming for this net zero building. So this building is LEED certified. It is I think it's a diamond or something, the highest part, the platinum part. So if you guys have like very interesting paper to do research on, TIC will definitely a place that you can consider to do your research from, actually. Of course, it will go through a very extensive level of interviews and whatnot. Okay, that's all I want to say.
Okay, thank you, Rudy.
Yeah.
Last of not least, one question for Mr. Chang. IAQ in intermediate lot, office lot. How can I maximize the IAQ? Only use aircon. lack
Okay.
of windows access for the middle part of the office.
All right. So if let's say this is with aircon and this is a ducted unit or centralized system, then shouldn't be any problem. We just need the fresh air intake to our air handling unit. Okay. So for our centralized unit, normally, okay, we can easily control the indoor air quality because I did mention just now, fresh air is the best solution, okay, to improve or to cure the sick building syndrome or to improve the indoor air quality. Okay, so if let's say your aircon, okay, you for example, okay, if let's say this is not the ducted unit, okay, this is the split unit, okay, at home. In fact, our cassette unit, if let's say you know what is cassette unit, the cassette unit which we install on the ceiling, okay, you just see the panel on the ceiling. So that cassette unit, in fact, we can draw in fresh air. Okay, we can draw in fresh air. So for this case, maybe if let's say you are using or you are installing with the cassette unit or the split unit, then you can install with the transfer duct or transfer air grill, okay, one by one from outdoor opening, then cross, okay, your other shop lots before that, okay, so above that ceiling, then you draw in the what I call the fresh air, okay, but you need to make sure that, okay, so it's, if let's say this is not too far away, then okay, because the static pressure, okay, if too long for the duct, then the static pressure will be quite high, okay, but normally for shop lot, okay, they are using the ducted unit, okay, then or a chill water system, then for me, I don't see any problem. We can improve, okay, so should be okay, so we can improve that, okay, for this shop lot, intermediate shop lot, okay.
Okay, thank you, Mr. Chang.
Welcome.
Mr. Rudy, we are near the end of this webinar forum. As the closing mark for this webinar, indoor air quality plays a part in helping of alleviate the effect of the current pandemic. In order to purifying our space for families, especially in the situation right now, and nurture a pool of competent workforce as required by the industries, the institutional of higher education have to keep on working closely with the industry to fine-tune our SOP, whether using passive and active solution to ensure that they are always updated to rapidly change technology and needs. Before the end of the webinar, I would like to thank two speakers, two expert panels we have here, T.S. Chang and Mr. Rudy.
Thank you.
Our chairperson and Dean of Faculty of Architecture, Planning and Surveying, UiTM, the organizers of the webinar, the Center of Study of Interior Architecture, concept webinar series, and the technical support team for making this webinar conducted smoothly. And the last of not least, the audience and the listeners, wherever you are. Every one of us, take care and stay safe. Have a nice day. See you again. Thank you very much. Bye bye from me, Dr. Zaf. Checking out now. Thank you so much. Okay, we can take a picture. If you can open your camera, all the technical teams, kita boleh buka kamera, kita boleh mengambil gambar beramai-ramai.